Let's begin with a bit of context. In November 2024, Anthropic announced an open protocol called Model Context Protocol, or MCP for short. So why was this necessary? At the time, the entire AI industry was rapidly developing its own agents, and enterprises were building out internal agentic systems to support them. The challenge, however, was that even the most advanced AI models were still limited by data isolation. In other words, agents were stuck in silos, unable to easily access or interact with external systems or up-to-date data. Every time a new data source needed to be used, it had to be custom integrated, which made it hard to build flexible, scalable agent systems. This is where MCP comes in. It was designed to standardize how AI connects to data, replacing patchwork integrations with a single, open protocol. This two-way connection makes it much easier for agents to access the data they need, with greater consistency and reliability. But first, what exactly is a protocol? Put simply, a protocol is a shared set of rules or standards that systems agree to use when they communicate. It defines how messages are structured, what order things go in, and what formats are accepted, kind of like a shared language between machines. For example, when you visit a website, the URL starts with HTTPS. That part, HTTPS, is the protocol. It's followed by the separator : // then comes the host, which is basically the domain name. That entire format is part of the communication protocol for the web. Now, apply that same concept to MCP. With MCP, the protocol name comes first, such as file, Postgres, or screen. Then comes the host and path. Together, these form a resource URI, which the agent uses to locate and interact with data. That's why many people compare MCP to USB-C. Just like how USB-C provides a universal plug, MCP provides a universal language for AI systems to connect to various tools, databases, and prompt sources, all through a consistent, open format. In short, Model Context Protocol, or MCP, is a communication protocol that helps you build AI agents and workflows on top of large language models and connect them to the databases and tools they need. Once you understand this, the next part becomes much easier to follow. Let's look at how MCP functions. MCP follows a client-server architecture, meaning there's a client that makes requests and a server that responds. At the heart of this setup is the user, the person who interacts with the AI through the application. This could be a general user, a company employee, or a developer, depending on the use case. Now here's how the flow works. The user interacts with an MCP-compatible AI application, also known as a host application, like Claude Desktop. Through this app, they can request things like querying a database, generating a summary, or triggering an external tool. But here's the key. The user doesn't interact with the MCP server directly. Instead, the host application includes a built-in MCP client, which acts as the go-between. The client sends instructions to the MCP server, using the MCP protocol to structure the request. Let's walk through a real example. Suppose a company employee uses Claude Desktop to ask the AI to pull a file from Google Drive and generate a summary. First, the user gives permission to access the file. Then, the MCP client connects to Google Drive's MCP server. That server fetches the file, processes the task, and sends the result back through the pipeline. MCP isn't just for cloud-based tools. It works locally too. For example, imagine a small business owner wants to check sales figures from a PostgreSQL database installed on their own computer. That's totally doable. With Claude Desktop, the app can connect to that local database using the MCP protocol, just like it would with a cloud service. It doesn't matter whether the server is running in the cloud or on your own device. MCP handles both seamlessly. And here's the cool part, MCP servers can do more than just deliver data. They can also trigger external tools or run actions as part of a workflow. We won't dive into those advanced features today. Maybe we'll cover them in a future video. If you're a developer, you can create your own MCP server or build an MCP client to connect with existing tools. Anthropic has published a quick start guide to help you get started quickly. To make things even easier, they've already released a list of ready-to-use MCP servers, including Google Drive, Slack, GitHub, Git, Postgres, Puppeteer, and more. Now let's take it one step further. Let's say an enterprise user uses Claude Desktop to fetch and summarize a document from Google Drive through MCP. At the same time, their internal AI agent, connected through A2A protocol, can reach out to another company's AI agent to help find qualified job candidates or even schedule interviews. So Anthropic's MCP and Google's A2A protocol aren't competing, they're complementary. MCP standardizes how agents connect to data and tools, and A2A standardizes how agents talk to each other. To wrap it up, Model Context Protocol, MCP is a standardized communication protocol developed by Anthropic. It allows users to access local or cloud-based data and tools via MCP-compatible applications like Claude Desktop. This reduces setup time, simplifies workflows, and helps agents work more effectively. Beyond Claude, other apps like Cursor and Windsurf are also integrating MCP, especially for development-focused use cases. That's it for this overview of MCP, the Model Context Protocol. You'll find links to official documentation and tools down below in the video description. Thanks for watching, and see you in the next one.